Welcome to this explainer. I am absolutely pumped to dive into today's topic because, honestly, it completely blew my mind. When we think about extreme sports, we usually picture pure adrenaline, raw physical power, maybe a healthy dose of fearlessness, right? But today, we're going to look at something way deeper. We're exploring this fascinating, almost hidden blend of extreme sports and applied mathematics. So grab your mental surfboards because we're paddling straight out into the hidden math of surfing. Just picture a surfer perfectly slicing diagonally across a crystal clear wave face. It looks entirely effortless. It's like poetry in motion. But to truly appreciate the math going on behind the scenes here, we have to look at the fundamental problem every single surfer faces out in the ocean. Sometimes, these waves form an 80-degree wall of water. Now, physically speaking, an 80-degree wall isn't really just a wave anymore. It's essentially a towering vertical cliff.
Okay, let's dive into this. What exactly happens if a surfer just points the nose of their board straight down that 80-degree wave? Well, if they do that, gravity completely takes the wheel. Riding straight down an 80-degree cliff is going to guarantee a terrifying, incredibly high-speed wipeout. The human body literally just cannot handle that kind of vertical freefall into shallow water. So, to survive and to actually ride the wave, surfers have to use a mathematical cheat code.
And that brings us to our core solution. What exactly is effective slope? This is the surfer's ultimate gravity hack.
The best way to understand this is to think of it as two totally different realities occurring at the exact same time. On one side, you've got the actual physical slope. This is the real, unchangeable angle of the wave, which we'll say is fixed right at 80 degrees. The ocean doesn't care about the surfer. That physical steepness isn't going anywhere. But on the flip side, we have the effective slope. This one is a variable. It's the angle that the surfer's body actually experiences. And the crazy part is, it is entirely controlled by the surfer, depending on their direction of travel.
So how exactly do they control what they feel? Well, here is the beautiful math behind the magic. It's the effective slope formula. Basically, it states that the tangent of the effective slope equals the tangent of the actual wave slope multiplied by the cosine of theta. Now, let's not get bogged down in the textbook terms here. Let's just look at the variables. Alpha is that terrifying 80-degree physical wave. Theta is the all-important angle of progression. If theta is 0 degrees, you're dropping straight down. If theta is 90 degrees, you're moving perfectly parallel along the face of the wave. Just by changing that angle of progression, the surfer manipulates that cosine value and completely alters the physics they're experiencing.
Let's actually look at how this formula plays out in reality on an 80-degree wave. At a 0-degree progression angle, which is straight down the cliff, the effective slope is exactly 80 degrees. You're going to feel all of it. But watch what happens as the surfer starts angling the board. A 30-degree angle drops the felt slope down to about 73 degrees. A 45-degree angle drops it to 67 degrees. But look down near the bottom there. If they can angle their board to 80 degrees, the steepness they feel plummets all the way down to just 23 degrees. Notice a pattern here? This relationship is completely nonlinear. The drop-off isn't even at all.
We really need to highlight that specific characteristic because it is absolutely vital. It's a nonlinear drop. The effective angles fall pretty slowly at first when you start to turn, but then they absolutely plummet as you get closer to that 90-degree parallel line. This little mathematical quirk perfectly explains that intense, oh my gosh, I survived feeling that surfers get. They're essentially in free fall, but by shifting the board just a tiny bit more at the absolute right split second, that terrifying vertical steepness just dramatically vanishes out from under them. So how does a surfer actually pull this off, out in the chaotic ocean? Let's talk about the bottom turn for survival. Let's walk through the exact split-second mechanics of this bottom turn. Step 1, the surfer drops in at 0 degrees. They are facing maximum gravity, literally staring straight down an 80-degree cliff. Step 2, at the absolute bottom of the wave, they forcefully engage the rail, which is the edge of their surfboard, right into the water. Step 3, using that rail as a pivot, they rapidly increase their progression angle, theta, throwing it from 0 toward 90 degrees. And finally, step 4, because of that nonlinear formula we just talked about, the effective slope drops instantly. The surfer miraculously converts that deadly vertical freefall into smooth, fast, horizontal speed, escaping the drop entirely.
Once they've survived that initial drop, we move into the next phase of the ride. Perfect balance, or trim.
This brings us to what's officially known as trim, though a lot of people call it line riding. This is the state where the surfer is actively maintaining their progression angle, theta, incredibly close to 90 degrees. They are riding almost perfectly parallel to the wave face. In this position, the surfer's main goal is really just to maintain their current momentum, making sure they don't accelerate out of control, but also making sure they don't fall behind the wave's power. Now, the absolutely crucial point here comes down to this single number, 0 degrees. Let's think back to our cosine formula for a second. If you're riding at a 90-degree progression angle, the cosine of 90 is mathematically 0. What that means is, to the surfer's actual body and board, an 80-degree vertical cliff mathematically feels exactly like 0 degrees. It feels exactly like you're standing on flat ground. We call this phenomenon zero gravity stability. Riding the line feels just like cruising on a totally flat surface. I really want you to think about how surreal this reality is. The physical wave is still right there, this towering, vertical, churning wall of water right behind them. But entirely because of their technique, because they've set their progression angle to nearly 90 degrees, they have essentially bypassed gravity. They're experiencing a flat, stable reality where the downward pull is completely neutralized. But let's be real. A great surfer doesn't just want to cruise. They want dynamic, explosive action. Let's look at carving to explode energy. Now they face a new problem. How do you generate speed from a flat 0-degree feeling? The answer is this brilliantly executed energy re-entry chain reaction. It's basically the exact reverse of the survival mechanics we talked about earlier. First, the surfer engages the rail to purposefully turn their board back down the wave face. Second, this action actively decreases their progression angle, theta. Third, by lowering theta, they mathematically steepen the effective slope they feel under their feet. Fourth, entering this newly steeper slope converts their stored potential energy right back into kinetic energy. And the result? Instant, explosive acceleration right down the face of the wave. To put that into real numbers for you, they are taking a super comfortable 23-degree cruise and purposefully slicing the board back, dropping their angle to recreate a steep 67-degree drop. By turning back toward a 45-degree progression, they are instantly hacking the wave all over again. They deliberately subject themselves to just enough gravity to generate a massive burst of speed via potential energy. It acts like a giant slingshot to fuel whatever massive maneuver they have planned next.
Let's start bringing this entire journey together under the idea of mathematicians on the waves.
This right here is the absolute core takeaway of our explainer today. Surfers do not fight the wave's fixed actual angle. Instead, they completely hack their progression angle to manipulate gravity. Think about it. The physical wave never actually changes shape. It doesn't magically become less steep just because someone happens to be riding it. But the surfer's technique dynamically alters their physical reality. Through these incredibly subtle shifts in board direction, they control the math. They literally turn vertical cliffs into flat planes, and then turn those flat planes right back into ramps for acceleration. I want to leave you with this incredible quote that I think just perfectly encapsulates everything we've learned today. Surfing isn't about reducing the wave's angle. It's changing your direction to reduce the angle you feel. That really gives you a mind-blowing new perspective on action sports, doesn't it? So, the next time you are standing on the beach watching a surfer shredding a massive, terrifying wall of water, ask yourself, are you just watching an athlete, or are you actually watching a master mathematician solving a gravity equation in real time?